The mysterious Blood Falls of Antarctica. Have you heard of the mysterious Blood Falls in Antarctica? This eerily gory waterfall is not in fact made of blood, but what gives it its unique color is truly fascinating. In this video, we'll explore the origin of blood falls and the secrets that lay underneath Taylor Glacier in Antarctica's McMurdo Dry Valleys. You won't want to miss the discoveries made by a team of scientists as we uncover the mysteries of the coldest glacier on Earth with constantly flowing water. Stick around till the end to learn about the microbes that live in these extreme conditions, providing clues to the development of life on other planets.
It's first discovered in 1911, but this is one of the few ones that are dyed a dark red color.
Location. Blood Falls was first spotted in 1911 by geologist Griffith Taylor, who was part of an expedition to the continent. The falls, which pour from Taylor Glacier in Antarctica's McMurdo Dry Valleys, were immediately striking due to their eerie red color. The glacier is part of a large ice field that covers a significant portion of East Antarctica. It's an area that's known for its extreme conditions, with mean temperatures of 1.4 degrees Fahrenheit or negative 17 degrees Celsius, and very little glacial melting at the surface.
That's minus 5.2.
Wow.
I need to put my glove back on my hand.
Celsius is how much Fahrenheit? Probably.
Despite these conditions, the blood falls continue to flow, and its red color has been a mystery for over 100 years. Red color. Let us tell you about the craziest thing we just heard about blood falls. So apparently, people used to think that red algae were responsible for the red color, but a study in the Journal of Glaciology has revealed the truth, and let me tell you, it's wild. The scientists used radar to scan the ice layers where the falls come from, and what they found was straight up bonkers. It turns out that there's a whole network of subglacial rivers and even a freaking lake under the Taylor Glacier, all chock full of brine that's super high in iron. And that's what gives the falls their signature red hue. But get this, the reason the brine stays liquid in those freezing cold environments is because it's got a ton of salt in it. And because salt water has a lower freezing point than pure water and releases heat as it freezes, it keeps the ice melted and allows the rivers to flow. I mean, we're talking about the coldest glacier on Earth with actual flowing water, people. And it's all thanks to some seriously salty water that's loaded with iron. Who knew science could be so metal?
The fact that it's so salty tells you it's not glacier melt, right? It has to be coming from somewhere else.
What's with the brine? The study also measured the amount of iron-rich brine in the river water and found that the brine content increased as the measurements drew closer to the falls. The researchers discovered that the water temperature and brine content were related. Cracks of various sizes in the glacier allow the brine to enter, and then the brine begins to freeze, releasing heat as it does. This heat warms the ice around it, increasing the brine concentration in the center of the cracks. The water is sourced from a brine lake beneath the Taylor Glacier, which over time has picked up iron from the underlying bedrock. The iron-rich brine, under high pressure due to the overlaying glacier, is injected through fissures in the glacier as it attempts to make its way towards lower pressures.
No one really has a super complete record of actual flow events.
How water remains liquid. At first, one might assume that the water should be frozen in place, given that it sits beneath a thick column of ice. However, several factors allow the water to remain as a liquid. The first is the release of latent heat associated with water freezing, which contributes a small amount of heat to keep the water above freezing temperature. In addition, water that is supersaturated in salt freezes at a lower temperature than fresh water. This is the reason that cities salt roads in preparation for winter storms. Finally, the high pressures at the base of the glacier also have a small impact in reducing the temperature at which water freezes.
If the water is clear and there's iron in it, that means it hasn't been oxidized yet.
Strange life. Blood Falls is truly a unique and fascinating natural wonder that has piqued the interest of scientists for decades. It is a mystery that has finally been solved, but it has only led to even more questions and intrigue. The blood falls also contain an array of microbes that can survive in extreme conditions. These microbial communities live off sulfates in the water and create energy via sulfate reduction. This process is similar to how humans convert food to energy, but instead of using oxygen, these microbes use sulfate. It's truly mind-blowing how life can adapt to extreme environments, isn't it? These microbial communities live in conditions that resemble the beginning of life on Earth, before oxygen was largely present in the atmosphere. They provide clues as to how life could potentially develop on other planets that lack an oxygen-rich atmosphere like Earth. It's like we're peeking into the past, trying to understand the origins of life, and the fact that it's all hidden beneath the surface of a glacier in Antarctica makes it even more fascinating. How to visit Blood Falls. Oh, so you want to see these falls? Well, it's not easy to get there. The location is in the remote McMurdo Dry Valleys, and access is heavily restricted due to the harsh and inhospitable conditions of the region. Most visitors to the dry valleys are scientists, researchers, and support staff who are there to study the unique and diverse environment. If you're interested in visiting Blood Falls, you will need to plan well in advance, as there are strict protocols in place to minimize human impact on the delicate ecosystem. You will likely need to apply for permission through the relevant governing body, such as the National Science Foundation or other similar organizations. Once you've been granted permission, you will likely fly into McMurdo Station, the main research hub in Antarctica. From there, you can arrange for transportation to the dry valleys, either via snowmobile, skidoo, or helicopter, depending on the conditions and the accessibility of the area at the time of your visit. It is important to note that visiting Blood Falls is not for the faint of heart. The conditions are extreme, and visitors need to be well prepared and equipped with appropriate clothing and gear to ensure their safety and comfort. Additionally, visitors must adhere to strict environmental protocols and follow the guidelines set out by the relevant governing body.
My view is Blood Falls is a pressure relief valve, that whenever there's a pressure change by a movement of the glacier, something happens.
Recap. So let's recap what we've learned today. The Blood Falls, located in Antarctica's McMurdo Dry Valleys, is not a waterfall of blood as its name might suggest. It's actually a flow of highly iron-rich brine that gets its red color from iron oxide. The brine is sourced from a subglacial lake beneath the Taylor Glacier and is able to flow due to several factors, including the release of latent heat during freezing and the high salt content, which lowers the freezing temperature. In addition to this, the Blood Falls also holds a unique collection of microbes that are capable of surviving in extreme conditions and using sulfates to create energy. These microbes offer important insights into the early days of life on Earth and how life can adapt to extreme environments, including other planets. It's truly fascinating to think about all the mysteries that are hidden right beneath our feet, waiting to be uncovered. I hope you enjoyed learning about the Blood Falls and its secrets as much as I did. Who knows what other hidden wonders are waiting to be discovered in the future? The possibilities are endless.
What got me interested at first was this notion of how life survives below ice because of other worlds.